How you doing? Peter Haney Jr., owner of Connecticut Axle and Spindle and Universal Driveshaft. So today we're going to walk around the shop a little bit and show you some things that we do with our drive shaft and our spindle and differential rebuilding. So we're going to start with the drive shaft stuff because we're kind of in this direction. And so this machine here allows us to do three things. We can weld drive shafts, we can balance, and we can also assemble. So by the fixtures that we have on the shelf, we can do all that without ever having to take the drive shaft off of the machine. It's a one complete system. We can phase the drive shaft in with the U-joints and the weld yokes. And then once we're assembled, we check our levels and check to make sure we dial indicate it, make sure we're close. And then we weld them up and then we check it again for dial indicator. And then we weld and balance. These rotate. Yep. And then once we get them built, and we'll do, I can show you one. So that once you're built and you turn the handles, right, then this floats. So as that floats, the needle moves, and that tells you how much weight to put on the drive shaft, and then it works like a timing light. So as you bring the knob in to touch it, it'll start flashing. If it flashes at 8, then once we stop it, we rotate this to 8. And you put on whatever weight that follows along with that needle bouncing. And some of it's a little bit of a guess until you get it in, but then once your needle gets down to a thousandths, then we know that we're right close there to where we need to be. So here we have our this is DOM tubing. It's about as straight as you get for tubing. It's designed for drive shaft assembly. The ends are machined for this size of the DOM. You can get DOM multiple sizes, but this here is 3-inch 083 wall DOM. It runs the truest as far as drive shaft material goes, and it makes assembly a lot easier. And this is how we start. These are our tube stands, and we start by putting our tube into the stands, and then we'll set our height to push it all together. So these are this is set for 3-inch. So when I set these in here, this sets my tube at 3-inch. So when I go to push the ends on, we're already straight in line. So these fixtures are all designed by the Shaft Master Company. So these are all made to fit, basically like a vacuum fit to go in there, which centers us up right down the line through everything. Okay, bring our tube up. As you can see, that goes in quite nicely because I had the wrong size tube for it. Okay, so here for demonstration purposes, because this is actually set up for a job that's coming in on Monday, I just got a piece of scrap here. So the idea is that the tube stands hold our tube straight in line. So obviously the longer it is, you set your tube stand down here. So then what we're going to use now is we'll use our 15-ton press. So this comes up here, slides the whole length of the machine. Here we've got a flat plate to press on there. This all goes in here, fits in nice and smooth. Then as we bring this up, as we bring this up to here, now we can use our 15-ton to push our piece onto the yoke. It's got a pin, we'll lock it in place. And we tighten down the nut. So now, once we hit the foot pedal, this here will then push the tube onto the yoke. So with the foot pedal, obviously, this is going to push the rod here through here. So as we come up on it, it's going to want to kick sideways a little bit. So we just knock it. So then once we push it on, and you look, we want to leave ourselves, I don't know, maybe like a 1/16 of an inch gap, so that when we weld, we bite right down onto both pieces, but then it goes right to the bottom of the tube. It's only 83 thousandths thick, but we turn it up to about 19 and a half volts on the welder, and then that will. So then what we do now is what we'll do is we would indicate this around here to get that within about 3 thousandths. Then we know that we're enough that when we balance it, it won't take as much weight to balance that out. Now, just for for demonstration, plate comes out, and then we would take a second fixture just like this here, turn that whole thing around, and the second fixture would go in here. So that's how you get your two ends of your drive shaft on. And we have one that we have already done this morning already, and I can show you how that looks as it comes together and as it's welded. All right, so here's a finished piece we did this morning. So here's the one end we just kind of showed you pushing on with the short piece of tube, and then on the other end is that same fixture. So we're going to push this one up to here, so it leaves about the same, about a 1/16 of an inch. And then we weld these on. So we have an automatic welder that rotates that machine at about, we'll say 5 RPM. And then as it goes around, it's just a MIG welder running that out. Once it cools, we spin it up, and we want to be somewhere down around 2000s, no more than 2000s run out. And we adjust that 2000s by the weights that we put on. Ideally, it gets down to 0 would be ideal, but they give you about a 2000s leeway as far as that goes at about 2600 RPM. So talking about size comparison, this is a 1410 U-joint, 3-inch 083 wall tube. Most of your 250, 350 pickups, dual wheel, single wheel, this is pretty common in those trucks. So as comparison, this is out of a Kenworth W900. This is a 4.5-inch tube OD by 250 wall. So that's a 1/4-inch wall by 4.5 round. So that U-joint, as you can see, that's about 1 3/4 or 2-inch cap versus 1 3/16. So you can see the comparison, but you're also talking about something that even with 600 horsepower, you can still run through this. That's 600 horsepower, but that's 2,300 foot-pounds of torque. And they brought theirs in because they actually sheared the splines off of this. This is the end yoke that drives it off the back of the transmission into that first drive shaft, and they sheared all the splines off. Okay, so this is the reason why the truck came in. Something happened, the U-joint failed, and it actually broke the ear on the U-joint, on the welded tube end. So what we did was we cut the tube off for him, and we probably could have used it, but there's a dent in there. And anytime that you start denting the drive shaft, it affects the integrity, and it rubbed on something there. So not even worth taking a chance for the cost of the tube. It's not worth it. So this is actually the replacement tube that we made for that. We were able to use one of his ends, and we had another one in stock. So we make this section of tube, which will then be mated to the other half of the drive shaft. Okay, so this is a slip yoke. Very common on your longer wheelbase pickups. This slides on here. And then what we'll do is this will then get connected to this, which carries the bearing. There's a bearing that rides right here. Carrier bearing underneath the pickups. That carries the drive shaft. So you run a 2-piece. This is called a 2-piece drive shaft as it runs down to the differential. So what we have here is this is the other half of building drive shafts. Not every shop uses one. They did tell us that when we first bought our drive shaft machine that there's 2 ways to cut your drive shaft welds off of the yokes. You can do it with a die grinder, which a lot of guys do that, or you buy one of these from the Dial company, and it's a 10-inch through hole, just a short lathe. As you can see, there's no rods. This is really not made for turning. It's purely made for cutting off that weld off of the yoke. So when you cut the yoke off and you get down into the tube and you go just through the edge of the weld, just take a hammer, you can slam the hammer and it'll take the end of the yoke right off. And then you can either use that end again, or if some guys have to shorten them, then you can just shorten the tube. Then you push it all back together on the shaft master over there and put it all together. But he said you use it once. He said you would never do it another way again. And this is, we've only had it for 9 months, and it's already paying for itself already just in the ease of use for the machine. So this is 4 9-inch, right? All your hot rod Mustangs, all your Broncos came with that. So this is a 4 9-inch out of a Pontiac, I'll be all right. Ford Lincoln town car, an older one. And what he wanted was they want to put this, I think, into a Mustang. And the housing was about 4.5 inches too long. So what we did was when he brought it over, we cut the ends off and save the ends, and with our fixtures, we can then put the steel bar down through the center. We have a fixture for the center and then a second one down here. So we slide the ends back on, and then we set our degrees. We weld these tube ends back on again. And we also rebuilt the center section for him too as well. So now this 9-inch will fit into his newer car. This is the third part of our business. So the other part of our business, other than the drive shafts and doing the custom housings and the rebuilding of differentials, is we also do truck spindles. So this one here came off of a Mack truck, and they were prone to fracturing the spindle itself. So inside here, you can see it looks like two big rings. This is where the spindle meets the housing. So the housing comes from this side, and they actually do a friction weld where they spin the housing high speed in one direction, and they spin the spindle in the opposite direction, and with force and heat, it creates these, looks like two double rolls. And over time, what you get is, just for whatever reason, is they fracture. The Macks were prone to it. I don't know why, but that's what it looks like broken. And then I'll show you what it looks like when we, what it looks like a brand new one looks like. All right, so this is one of our brand new spindles. These are all CNC made for us. And I believe they're made out of 1020, I think, steel. And what they do is they put a machine center in the back, and then obviously the center out here is set to the same OD as this, so that when we put in our lathe on the job, we know that this is going to run as true as possible. So these are made bigger than the housing, so we actually turn these down on the job site so that they'll fit back into your housing. So they're actually thicker. They're thicker than a standard spindle, because you've got all that material there backing it up. Plus it goes inside the housing, so your chances of it fracturing are a lot less. But these are made to identical replicas of the factory spindle, so all your bearings and seals fit right on. So, all right, so comparatively, this here is a trailer spindle set for your 20 or 40,000 pound trailers. Most of your 48s and 53s all run a similar spindle to this. Some are, this is what we call a tapered spindle. It's got a bigger inner bearing, smaller outer. Some are actually straight, where it's the same bearing, inner and outer. That was the old Pro Pars. But this one here is made so that we can interchange a collar on the back. Some of the housings are made 6 inches around. Some of the housings are made 5 inches around. So it takes a different collar for the back, and then we weld the fronts and the backs. And then once we set this in the housing, then you weld the collar to the housing. So it allows us a little bit of mobility. And also they're drilled through the front, so that if you have air systems on your trailers, you can put the air system right back into the center of the spindle. So comparatively, same thing. This here being good for up to around 46,000 pound rears. This is a GMC 1 ton that you find in any of your late 70s right up through today's trucks. Uses about that same spindle for the GM trucks. And Ford and Dodge, same thing. That's just a 1 ton spindle. So this one here is a little different yet. This is Mack specific. Some of the Mack trucks, you guys will know their own Macks, know about them. They had a cast steel housing. Well, you can't weld the spindle back onto the cast housing. These are actually sweated in. So it's a matter of, we punch a hole in here. You have to basically red hot the casting and a 60-ton pull, and you pull the spindle out of the housing. And then putting them back in again, same thing. Got to make sure that housing is good and hot. And we set these into a predetermined length from your bearing journal out to your threads. And that's how you fix those. And those are only on the cast housings. Other ones that they have are called the stamped steel or the fabricated housing. That uses a standard spindle like we showed you earlier. And so this is like Mack specific. Same thing, just another variety of a Mack with a cast housing. This is more of what they would call a heavy duty or heavy 44 Mack. Same parts from here out, just the way that goes into the housing, it just steps it in a little bit farther. So there's actually 3 different steps in the housing. Same idea, you punch a holes out here, 60-ton pull, warm the housing up, and then these are actually pulled out of the housing. Once they're put back in and they cool, there's actually a 1.16" hole where a bolt head that we have to drill into the spindle, and believe it or not, that's actually what retains it from ever coming out. It would take, the last job we had, it took them over a year for that spindle to work its way out because nobody put the bolt back in. So it will work its way out, but it'll just take time.